Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the data structure section called the tree level order traversal. And for this particular challenge, given a pointer to the root of a binary tree, we need to print at the level order traversal of this tree. In level order traversal, nodes are visited level by level from left to the right. You can complete the function level order and print the values in a single line separated by a space. And we are going to use System.out.printf with the percentage and d, and then we pass in the second parameter as the data that we need to print from the node one by one by the separated by a space. And for the example right here, we have the structure of a tree node, which is 1 who has the right property of 2 and has the right property of 5, and 5 has the left property of 3 and right property of 6, and then finally 3 has the right property of 4. And from the function of the level order, we need to print in order like this, starting from the top, which is the root node, and then finally the going to the lower part, which is on the node 2 right here, which is the child part, and then 5 is being printed, and then 3, and then 6, and then finally 4, because 3 and 6 is on the same level and 5 is on the above level, the 3 and 6, and then 4 is on the below level or the bottommost level. So that is the order that we need to print, from the first row, and then second row, third row, fourth row, and then finally the final row. So that is the level order traversal that we need to complete. And we have the public static void function, which is not returning anything other than using the System.out.printf. And this is the level order, which is the function name that takes one parameter, which is in the form of node class, from the custom class right here, node with the property of data, and then left as another node, and then right property as another node. And it takes one parameter called the root as the parameter name, and we are using the Java 7 as our language. If you want to use something else other than Java 7, then go ahead, I encourage you to do so. And let's solve this challenge. We have the first constraint right here, only one constraint, which is the number of nodes, at least one node, and an inclusive number to the 500 nodes. And let's solve this out. If you notice from this is fairly similar from based on the previous challenge called we are on the tree at the top view. From the previous challenge, we are using the BFS and custom class of the queue object, but for this part of the challenge, using the level order traversal, we are not going to use the class, but we still use the BFS or the breadth first search algorithm, and we still use the queue to queue from the top level and then to the bottom level, each one by one. And I don't think we are not going to use the map right here, because we are not mapping anything. We are just printing the order of the traversal from the topmost to the point to the bottommost part. And we don't use a map, unlike the previous challenge called the top view, that we need to determine the surface level to check if it is stated as the top view. So that is why we are declaring the coordinates only on the surface level, and that is a slightly different approach from our current challenge. And we still have to use the queue add, and then using the while loop, while as long as the queue is not empty. And this is the root of the core of the BFS approach. We are just iterating over the current queue to be processed about, and then we need to destructure the object from the node from the queue using the poll method, and then we check if the left or the right is not null. But for this top level approach, level order traversal, we have to consider that we need to do in order, like we need to declare the top side, and then we need to declare the left side, and then the right side. So that is the order of the approach of this challenge, and we have to be mindful about placing this if else to check which one has the as the left and right property, and left takes the priority over the right one, and then we should add the queue to the end of the list. And also for the after the left has been completed from the iteration or from the traversal, then we need to add the right part to the queue, to the last element of the queue. And then we need to use the for loop to print everything from the data from the level order approach 1 2 5 3 6 and then 4. So that is, we need to reiterate over the data property from each node based on the level order approach. And I'm going to use this similar challenge from the previous one, but we need to slightly modify it in order to solve this level order. Let's solve this out by creating a new queue with the data type of the node. This is the type of the node called the queue, and we don't have to use the custom class of the object queue or the queue object. And we need to declare a new linked list. Since we are working with the node, then we can type the linked list as the universal type of the angle brackets that is not filled with anything. You might want to use the node filled inside the angle brackets. But for this particular challenge, it is fairly okay to not use the node as the type from the inside the angle brackets right here. And as we already know that Java is also strictly typed, just like using the TypeScript. And for the next one, we can use the list. We use the array list that consists of all integer, and then we declare the number called the answer, and we declare new array list consisting of the integer. We construct new array list, and we are going to queue from the top and then left and then right, from the top and then left and then right again. So add it to the queue, and if we want to use to process the queue, we can use the queue poll to remove the element from the queue or the node from the queue, and then process that element into the array of the answer, and array of the answer will be filled with the data from the desired order that we want. Okay, so for the next one, we need to declare the initial value inside the queue using the queue dot. Instead of using the add, you might want to use the add, but I'm going to maintain the consistency by using the offer method. It is the same as the add, but add will return an exception, just like on the remove method, remove versus the poll. But for the add is versus the offer. So offer will return null if the queue is already filled to the prim or it's already full. We need to offer the node from the current node, which is the root node, and then we are inserting the root node inside our queue linked list as the linked list constructor right here. And we can use the BFS approach just like on the previous challenge, like this one, using the while loop. While as long as the queue is not empty, using the while loop, while the queue, I'm using the exclamation mark in front of the queue is empty method to determine if it is not empty. As long as queue is not empty, we need to destructure our queue using the node of the current node, and we need to type the queue and then poll. That way, polling will remove the first element of the queue or the first element like from the offer. Let's say we are using the queue offer right here. Since the initial value of the queue is already empty, then the queue offer will insert the root as the current queue, and root is placed on the back of the structure. Let's say we already has the value of the root dot left from the, I'm using the parent root dot left. Let's say the queue already stated like this, already filled with the parent root dot left, and if we use the queue offer using the root itself, then we are adding root to the end of the queue instead of the in front of the queue. So that is following the FIFO principle, or the first in and first out. If we use the queue poll, If we already have the parent root dot left, the parent root dot left will be processed into as the current node, and it will be deleted from the poll after the poll has been completed, and the parent root will be processed or destructured inside the current node variable right here. And we are inserting root into our queue. I'm going to use a raw visualization like this, and we destructure the root as the current node. And for the next one, we need to utilize the current node, data into the list of the integer using the answer with the method of add the current node dot data. And that way we are inserting the current node data of the node 1, since 1 is on the root side. Then after that we are inserting 1 as the answer array like this. See, inside the array list is supposed to be like this, using the curly brackets instead of the square brackets, just like a usual array. And for the next one, we need to mind the order, and we use if check to check if the current node dot left, we can access the left property, since we already destructuring the root node from the queue.poll from the start of the node. Not from the start of the node, but the start of the queue. We are removing the first element of the queue and process it into the current node. Check if the current node dot left is not equals to null, instead of using the exclamation mark in front of the current node dot left. You can check if it is not null, not as long as it's null. If it's not null, then we need to insert this into our new queue using the queue offer and offer the current node dot left as the parameter, and that way the queue offer will insert the queue with like this. Since root already removed from the poll method right here, then the left will be inserted like this, current node dot left. And then the next one, using another if check, if the current node dot right, after we process the left, then of course we need to process the right property. If right is not null, and then we have to mind of the edge case, since the left right here is already null, then we don't have to insert the queue offer using the current node dot left because it is already null. Then we need to insert the 2 as our answer array of the next while loop iterator or while loop traversal. Then we need to use the queue offer of the current node dot right, and that way we are inserting right into our queue like this, queue, and then equals the current node dot left, and then comma current node right. Oops. And finally, we need to use a for loop if everything has been completed. Since we already inserted the current node left and current node right, then while loop will not stop and it will starting from the top again. Queue is not empty, then we need to process the current node dot left, and we are removing the current node dot left from our queue variable, and current node dot left will be removed and it will be processed into our current node. So this is the state of the current node dot left, and we are processing the current node data. Since left is already empty, this one is the example if left is not null. And since it is already null, then we already inserted the current node dot right, and current node dot right is going to be empty, and then the answer add will be inserting the data of 2 into our array. And then we are checking the left. If left is empty, since it is empty, then we need to insert 5 into our node from the right if check, and then the queue will insert as the current node, which has the data of 5. This is the rough visualization. Then we have node 5 into our queue, and then 5 will be processed and 5 will be removed from the queue, and then answer add will inserting 5 into our answer, and then checking if left is null. Since left is not null, then we adding the left, which is the 3, node 3, and then we are inserting the right. Since right is not null, which is 6, then we inserting, since it is already 3, then we need to insert 6 at the end of the queue. Then the queue will be filled with the 3 and 6, since it is destructured by the queue.poll, then the 3 will be removed since 3 is on the front of the queue variable, and then 3 will be inserted as the answer array, and checking if the left is null since 3 has no left property and only the right property, then the q will be 6, and then q will be 6 with the value of 4 because the 6 is still added to the queue and not being processed yet, and then 4, which is on the right side of the 3, will be inserted as the queue after the 6, which is 6 right here, and so on and so forth. And finally we need to declare the for loop for integer I iterating over the answer array of the array list as long as I equals to 0, as long as I is below the answer array dot size. We are determining the size, and then I plus plus. If it hits the size array or 1 below the size array, then the for loop will iterate the last element and it will stops. Then after that we need to use the system.out print line, system.out.print, not print line but printf with the percentage and d with the space separated line on just a single line, and then we need to pass in the second parameter as the answer get is in the get method, and get the current index, which is the I, determined by the I. So let's run the code to see if it works. Let's submit our code, and we have the correct answer. So we can optimize this further by removing the answer array from our array list. We don't need this at all, and we can just directly insert this using the System.out.printf, and we need to eliminate the for loop that is unnecessary, and that way we are just inserting the System.out.printf using the percentage d just like the usual format, and then instead of using the answer.get as the second parameter, then we can pass in the current node dot data as it is. Then you don't have to worry about it because it is already printed. It is going to be printed as the System.out.printf answer as the single line digit with the space separated, and we can just run this again to see if it works. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.